Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be talking about RISC-V and some of the updates that I learned from the conference on Friday. So these are updates for September 2020, right after this. So Friday was the RISC-V's Global Forum conference, and usually that's held out, I think, in San Jose usually. But unfortunately this year, due to the human malware situation, they did it as an online conference. So they started at midnight on Friday morning in the U.S. and went until about 8 p.m. or so. So I wanted to cover some of the highlights about that with you. So before we jump into that, though, it probably would help if you're not familiar with the RISC-V International, probably need to explain a little bit about what it is. So RISC-V is an open source hardware instruction set architecture, or ISA. In other words, the instruction sets are published. You're free to look at how it's implemented. You're free to use them in your designs. You don't have to pay a license for those. And the RISC-V International organization as a whole is a nonprofit entity serving members of both the RISC-V International as well as community members and industry outside as well. Their mission is to accelerate RISC-V adoption and explain those benefits that you get to the community at large. RISC-V as a concept is 10 years old. So they've been around in a very short period of time in terms of chip design and chip architectures. That's a very short time to be around. But RISC-V is not an open source processor. In other words, it isn't a free and open source processor because, after all, it does cost something in order to commit designs to silicon. What it is, it's an open specification of the instruction set itself. So anyone can build a processor that utilizes the RISC-V ISA, and provided, if you have your own fabrication facilities or you know someone that does. The RISC-V Foundation International was created 5 years ago, and the RISC-V decision to create their own ISA occurred 10 years ago. Today, though, RISC-V is being widely adopted. I've heard people say, "Oh, it's just an IoT standard." No, it is being widely adopted in academia and in research. But I think you have to look a little broader. There's also a lot of interest by industry and commercial companies that are interested in utilizing this specification to build processors for their own use. So, yeah, there's still some gaps in the application areas, but I suspect that if it's something you're interested in doing, they'd be more than willing and more than happy to have you join and work with them. The RISC-V International manages the ISA specification. They provide the golden model for that ISA instruction set. Golden models usually mean that it's immutable. In other words, that standard will not change. So I'm not quite sure how they plan to go forward, because over time there's always new things that are added to any instruction set on any processor. But I guess time will tell. They didn't really talk about that too much, but you got to walk, you got to crawl before you can walk, you got to walk before you can run. So they're doing really well for where they are. The RISC-V International is also, of course, responsible for creating compliance tests, which allows you to, once you've taken the ISA standard and you've started to simulate or build it onto FPGAs, field programmable gate arrays is what those stand for. So those are usually the steps you take into prototyping chip designs before you commit to silicon, because that's very expensive and you don't want to do that more than about once. People usually get fired over that one if you commit more than once. But yeah, there are revisions that occur over time, of course. But the original project goals were I guess I would say, modest by today's standards. And it was born out of need and probably a little frustration. But they've become the industry standard ISA for all computing services devices is what their original goal was. So they wanted to be ubiquitous, be installed everywhere. They wanted to build a simple and efficient, extensible ISA for research, so they could figure out, new ways to do things and create application-specific processors in the course of that work. They didn't want to bake any technologies in or any microarchitecture designs. They wanted to stay free and easy to modify, but also easy to document and easy to teach. They didn't want any barriers that would prevent them from sharing their outcomes and research findings with other colleagues. And I think that was one of the main problems they had with the other processors in the industry, that they're closed, and once you've signed the license agreement, you've committed yourself to not sharing any of the things that you do or that they do with other people. So yeah, that's unfortunate, but that's just the way things are. So I think the reason why they designed this standard was to get out from underneath of those legal requirements. So, but they also didn't want to create their own compilers and linkers and libraries and utilities and performance tools, all those kinds of things. So they didn't want to be bothered with that because that's not what they do. So they wanted to be able to take advantage of those things that were already in existence. They also wanted to have a standard operating system as the mechanism by which to implement a platform, and Linux, of course, is chosen for that. The goals, objectives in 2015 kind of modified a little bit. They wanted to get industry on board. They wanted to get people that would back this and would provide financial assistance. They also wanted to avoid fragmentation because that always increases the cost in doing anything, because once you fragment, then you have to replicate your changes from one platform to another. They also wanted to enable a broader participation in the spec development. So they didn't want to just be an academic exercise or a teaching tool. They wanted to expand this to include real-world applications. But they did not want corporate hijacking. In other words, they didn't want to lose their standard over to some proprietary way of doing things. Some 9 goals were to create a unified community, and I think they have definitely achieved that goal. They also wanted to avoid endorsing implementations. So, in other words, they didn't want to be a favorite son of some company's favorite way of doing things. So they didn't want to really get involved in that. They also didn't want to be the people that were providing the engineering support and resources to develop projects. They're there for a purpose, and that purpose is to teach and to use their ISA to help new students learn how to create new processors and new architectures. The goals in 2020 have refined a little bit more. So they really want to be able to change their business model, but they don't want it to change anything else. So they want to be able to, I guess, be able to focus on different areas as they see fit. But they want to replace the proprietary ISAs that are out there with free and open ISA through the RISC-V. But at the same time, they want to be able to run all existing software. That's a pretty tall order. That takes a lot of work. And they wanted it also to fit into existing SoC designs. One of the areas that one of the vendors was talking about was taking the chip and placing it on an SoC and using kind of the standards that are around today for like the ARM-based SBCs, and integrating those with existing ways and existing controllers. That would be you have 2 parts to a system on a chip. One is, of course, the CPU, but then you have the memory, all the hardware integration, like the device drivers for networking, the devices that you need for graphics, for USB support, for your storage devices, and so forth. And one of the things that one of the companies was sharing with, I think it was on the Pico Rio, was that a lot of the implementations of these controllers are closed, and so they're thinking, well, I guess the only way we're going to keep this whole platform open source, because that was their goal. That's nothing to do with RISC-V International. That was the goal of this company, is to have an open source SBC. So in order to do that, they're going to have to develop their own. And so it's becoming a much larger project than I think they really had intended. But they are creating their timeline to stretch it out so that they can do this in a more timely fashion. Of course, the bigger interest to them is just getting it to work, right? So, but most users don't care about what ISAs they use. I mean, if you bring home a new computer, or you bring home a new television, or a new phone, you don't care what instruction set's in it until things go wrong, until things go horribly wrong. And I think a lot of the focus came up a couple of years back with Spectre Meltdown. All of a sudden, we were caring about what was going on in the instruction set architectures. So yeah, it's only when things go horribly wrong that we wake up and go, uh-oh, this affects me. So even though Spectre Meltdown hasn't been an issue as far as a real-world exploit, it's still, there have been other areas of that chip that have been exploited, and so that then becomes a trust issue. So once you get that point, it's really a trust issue, and then what do you do beyond that? Anyway, the priorities for the RISC-V International is to run all software, but be feature complete. They want enough instruction sets or instructions in the architecture to be able to handle the widest variety of applications they can support. They also want to remain stable, and yet they want to support innovation, which that seems to me to be, and to the leadership as well, it seems to me to be a little bit in conflict. But you always have to manage those two together, right? You have a legacy environment that you're trying to create and maintain, but at the same time, you're trying to push forward new designs and new architectures and new instructions that you need in order to support future applications. Because we don't know what the future is going to bring. The future always brings change, that for sure. We always know that. I wanted to talk about just some specific areas about where some of the functional innovation is taking place. NVIDIA is using RISC-V in every graphics card they make. So, and they said during their talk that it's been going on for at least 3 years. So that leads me to believe that the RISC-V may have started to appear in the RTX 2000 series of cards, and they have no plans to remove it. They're continuing forward and continuing to use it. It is a high-performance accelerator that's used in those graphics cards for deep learning workloads, but also it serves as the I/O controller to bring data in and out for the GPU to work on. So that is a RISC-V processor that's in there. Western Digital is using RISC-V for their storage controllers, and Hex5 has created a multi-zone security mechanism for multi-domain secure execution environments using RISC-V. That is a very big deal. I mean, everything I've read about anything with containers and virtualization and network-based transactions has always gone back to multi-zone security, that I need to be able to provide support for open areas that allow me to have free flow to the internet, but then I need to have areas within there that are zones for financial transactions and deeper zones for company internals, proprietary IP, and that kind of thing. So yeah, I mean, that is a real big deal. And sorry about that. And Google has launched, along the lines of security, has launched OpenTitan. And they have a number of industry partners that are working with them to do that. And that is a cryptographic coprocessor with a inbuilt hardware random number generator to create key hierarchies, defense mechanisms, secure boot, all those things that you need in it to maintain a secure environment. So that is another big deal. And in some of the older cryptography technologies, such as RSA, DSA, TLS even, well, it's really repeating RSA, but TLS to some degree, is everything is based on the random number key generator, and what we have seen over the past 20, 30 years, that has not always been the best thing. Has not always worked flawlessly. So yeah, the TNRG has replaced that, and that seems to be okay for now. But again, it's a proprietary implementation that we don't really want. The other implementation is in high performance computing, and really and beyond that as well. So in 2015, the European Union Commission president was concerned. He was concerned that the supercomputing resources were not in Europe. They were in China, they were in the US, and he didn't want that. He wanted Europe to have their own base for supercomputing that was using their own technology, their own processors, their own servers, and it was based and hosted in Europe. So out of that, in 2019, the initial steps to start to build that, they have to do they have to find out which processor they want to use. So they formed the European Processor Initiative, which was to begin a prototype phase in designing the processor that would go into the European supercomputer. And RISC-V is currently under evaluation for that. In fact, I don't know if they're evaluating. I think they're taking the design all the way down for that right now, because as Jean-Marc Denise said, that they really want this open standard because it allows them to have the most freedom within their choices to build the hardware architecture around those. So the short term is to supply a CPU and designed and manufactured in Europe. And one of the things that he talked about was initially they can't get to 7 nanometer because it's just too expensive and they don't have the budget to support it. So they are going to use 22 nanometer, I think is what he said initially, and that's okay. I mean, that's fine. You're trying to figure out if this is really going to work or not. You know, you don't need to spend millions and millions of dollars to commit a design to 7 nanometer architecture when you're not even sure it's the right thing to use. So yeah, I don't blame them. And they're moving forward with that design to see if it will flush out and become the supercomputer for Europe. However, Barcelona, also their supercomputing-centered development for RISC-V, they're working on something called the Lagarto processor, and that's being built with TSMC. Now, it says 65 nanometer transistors. I don't know if they really meant 6 or 5 nanometer, but anyway, 65 nanometer is fine. I mean, again, you don't want to commit to silicon until you're certain that this is going to pan out. But so their first RISC-V ISA chip is going to be built in Spain for that project. RISC-V, the European space platform, is also using RISC-V to design a platform for space and aviation. So it's more than just an IoT device. So yeah, it's much more than that. Projections that they talked about were they think that RISC-V will reach 62.4 billion CPUs in 2025. That is a heck of a lot of CPUs, and they think the bulk of that will be industrial, as you can see from the graph. The bulk of that, consumer devices, it'll be a sliver, of that, and I guess the other major one would be looks like transportation, possibly. So, yeah, I mean, right now there aren't very many RISC-V processors in existence. I mean, there's a few that have been around for a while, and there's some more that are coming at the end of this year. But yeah, the areas of influence have been in embedded. There is PolarFire that has a low power field programmable gate array, which does that. Also machine learning. Alibaba, of course, they announced their 16-core machine. I think it was a couple of years ago now. And the in-core semiconductor family of RISC-V core for deep learning. Sony Semiconductors for AI integration, and Switch Science AI's camera will be going into the support for RISC-V as well. Also, high-performance computing, we talked about the European Processor Initiative already. Other areas are Internet of Things. Greenwaves has a high-performance machine called the GAP8. GigaDevice launched a general-purpose microcontroller, and it's relatively small, but I mean, you're talking sizes here of around a Raspberry Pi Nano, somewhere around in there. Virtual reality, Facebook is working with their Oculus team, is working with RISC-V. Wearables, Huami has a 1S processor on 7 nanometer with RISC-V. I think, I'm not sure, but I think Wearables is the largest chip supplier for wristwatches and that kind of thing. Also Fitbit, that kind of stuff. So that's an interesting one. And then wireless, Samsung plans RISC-V cores in their mmWave radio frequency of its 5G cellular modems. So as on the small side, yep. But what about us? What about on the Linux side of things? So Yocto has been working on a high-end 64-bit implementation for Linux. And of course, they say embedded distro, but that's not really fair. Yocto does a lot more than just embedded distros, but I'm sure that they're concentrating first on that. OpenSuse is creating have created a RISC-V implementation of their distro. Fedora released one, I think it was in February of this year, and that will eventually roll up into Red Hat. It's not there yet, but eventually will roll up into Red Hat. Ali.io is a operating system that's similar to Android and Linux from Alibaba, which uses the Alibaba RV 64-bit chip. There's quite a bit of interest and support, like in the Pico Rio SBCs, for ChromiumOS support, or Chrome OS. And they're building in support for the V8 JavaScript standard and also Node.js, which is, so you have the front side with V8 and then the back side with Node.js support. And that's, of course, using the Pico Rio SBC. That's the one where they're having challenges with the closed support on the SBC for the devices that they're having to deal with. Open source, of course, the GNU toolchain has been done for some time, and that runs on RISC-V. LLVM supports RISC-V, and QEMU Virtual Machines has joined the RISC-V support as well. So the RISC-V specification, it's the same for every company. So and that creates a level playing field, at least from the ISA perspective. Companies using RISC-V are then forced to differentiate their products using either the SoC, the chips around it, or the SBC themselves, or designing. They're free to take the ISA and implement it in 32-bit, 64-bit, 128-bit, whatever they need. So that's how they will differentiate themselves in the marketplace. But that benefits us because that creates, first of all, a mechanism where I have some assurance that I can write my code for RISC-V and expect it to work. So no matter what platform it's on. And also it forces the companies that are developing, they can't just do just enough to keep us happy. They're going to have to face their competition and out-innovate them in order to stay viable. So yeah, so they have to keep viable. That gives us better products, and we get to move around freely. Yeah, what universe are we in? Yeah, well, anyway, it is a great idea. The RISC-V Foundation reported 660 plus members as of September 2020. It is definitely growing, and this chart is quickly becoming an eye chart. I know the first time I did this, there wasn't a whole lot on there, and now it's stuffed. I don't know what they're going to do after this. They may have to just go to a blur chart, just a bunch of alphabetic logos scattered all over. But yeah, it's growing very quickly. So that's what I wanted to cover today with you. I just wanted to give you some highlights. If there's something of interest that you might have about RISC-V, maybe there's something else you'd like to know about it. Just in conclusion, I know that there are some processors that look like they are viable to build as workstations. Well, maybe not workstations, but maybe as low-end workstations that are coming at the end of the year. and a whole lot more coming next year that seems to be building up into the Chromium style laptop type of implementations, up into some of the smaller gaming machines for laptops and also home servers. So I don't know beyond that where it might go, but who knows? I mean, it just depends on us. We're the ones that are going to drive this, because the companies will do whatever it takes to make money. So as long as there's it's commercially viable, they'll come around. They always do. Anyway, I hope you enjoyed this today. If you did, please like and subscribe. And as always, hope to see you again real soon. And if I can find this, bye for now.